How do we use the law of cosines to solve oblique triangles? Well, first we need to know when to use it. There's two cases whenever we need to use the law of cosines. One is if we have side angle side. So if you're given some triangle and you have a side, the angle in between and another side, we can use the law of cosines. And the other case is if you have side, side, side. So some oblique triangle, and you have the lengths of all three sides and no angles. Okay, so what is the law of cosines? Well, we can write out the law of cosines three different ways for each of these angles and sides, but it's pretty much the same thing each time. If I'm looking for this a, I can say, okay, a squared is equal to the sum of both of the other sides squared, b squared plus c squared. And that looks a lot like the Pythagorean theorem, right? Minus 2 times those other two sides times the cosine of the angle. So if I have an a out here that's set equal, then that's the angle that I'm using. Okay? If I want to do b squared, it's the other two sides, a squared and c squared, minus 2 times 2ac times the cosine of b. Finally, if it's c squared, do the other two sides, a squared plus b squared minus 2ab times the cosine of c. Okay, so some quick notes. If you're solving side angle side, you have to pick an equation based on the angle that you know. So if you know angle A, then you use the a squared equals b squared plus c squared minus 2bc, whatever. And remember, whenever you're solving for that third side, you're going to have to take a square root. If you're solving for side, 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 just remember, if you're solving for an angle, you have to use the inverse cosine and solve for the largest angle first. Alright, so we're looking at a triangle with sides 14, 8, and 19. So this is a side, side, side. Let me know that I need to use the law of cosines. I'm going to go ahead and assign names to each of these sides. This 19, since this is my largest side, this will be my side C, and across from it will be angle C. Other than that, we have angle A, so I can say 14 equals A, and this will be angle B, so 8 equals B. Okay, so I need to solve for the largest angle first. So I know this 19, so I'm going to be using c squared equals a squared plus b squared minus 2ab times the cosine of angle C. Now I just fill these things in. C squared, that'd be 19 squared equals 14 squared plus 8 squared minus 2 times 14 times 8 times the cosine of C. Okay, so we have 361 is equal to 260 minus 2 times 14 times 8 is 224 cosine of C. Alright, so be careful to remember your orders of operation. Next you need to subtract 260 from each side. So I have 101 equals negative 224 times the cosine of C. Now I can divide both sides by negative 224. And that'll give me negative 0.45, and then it keeps going. 0.89 equals the cosine of C. Whenever you're doing this, even if you don't write down all the numbers, just keep them all in your calculator and hit the inverse cosine of that. So inverse cosine of that last decimal that the calculator gave us equals C. we see that the angle C is 116.8 degrees. Okay, so if this is 116.8 degrees, now I have a side and its opposite angle, so I can use the law of sines for the rest of it. I can set up two more problems. I can say, okay, then the sine of 116.8 over 19 is equal to the sine of either A or B, is equal to the sine of angle A over 14. And I could cross multiply and divide. Okay, cross multiply and divide. 14 times sine 116.8 is about 12.5, and that equals 19 times the sine of A. So I'm going to divide by 19, and that'll give me 0.657, and then I'm going to take the inverse sine of that to get A is equal to 41.12 degrees. Now, I already had all three sides. I could use the law of sines to figure out the third angle. Or what else could I do? Yeah, all the angles add up to 180. So, I have 41.2, 116.8. I can just take those away from 180 to figure out angle B. So 180 minus 116.8 minus 41.12. This will give me angle B. So my last angle was 22.08 degrees. Okay, so we're told that side B is equal to 10, A is equal to 15, and angle C is 115 degrees. So we have to draw out this triangle. Alright, so 115 degrees, that'll be our biggest angle. So this is 115, and we weren't told side C. I was told side B was 10, so on the opposite side we have angle B, and side A is 15, so opposite that we have angle A. So this is a side angle side, letting us know that I can use the law of cosines. And whenever it's side angle side, remember that we pick the equation based on the angle that we know. So we know angle C. So I'm going to start off just like last time with that. C squared equals A squared plus B squared minus 2AB times the cosine of C. And I'm going to solve for the side C. So C squared equals 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 115 degrees. Okay, so after just plugging in that entire side, we have C squared is equal to about 451.8. So if I'm actually solving for side C, I'm going to have to take the square root of both sides, and I see C is equal to 21.3. Okay, so we have all three sides in one angle. So now, since I have a side and its opposite angle, I can use the law of sines. So let's solve for angle A. I know that the sine of 115 over 21.3 equals the sine of angle A over 15. Once I cross multiply and divide, I see that the sine of angle A is equal to 0.638. So doing the inverse sine of that, angle A is equal to 39.7 degrees. So fill that in on my triangle, 39.7 degrees. I have two angles out of the three. To solve for the third angle, I just take those both away from 180. So angle B is 180 minus 115 minus 39.7. So my last angle B is 25.3 degrees. And that's all for law of cosines.